In this video, I want to talk to you about smart thermostat controls and why that matters for hydronic heating systems. So hydronic just means water-based, and that's the kind of thing that a solar heating system is going to be. So imagine this is a thermostat, and let's say I've set it at 72 degrees. Now, this thermostat, let's just imagine that it's controlling a pump, and the pump is supplying hot water to a radiant in-floor heating network. So when the thermostat detects that the room is colder than 72, let's say 71, it is going to energize this pump, which is going to send some hot water through the floor network and warm up the room, and then go back for heating in your solar heating system. So technically, as soon as that temperature rises to 72, then the thermostat will shut off the pump. The problem with hydronic systems is that there's still going to be a considerable amount of hot water sitting in the floor. And depending on the outside temperature and depending on how fast your room loses heat, it can still continue to heat the room. So a normal thermostat, all it can do is shut off the pump, but it can't control how much extra heating happens. So it's not unusual, especially during the springtime when you've got a lot of solar energy coming in windows. That 72 degree set point, that could rise to 74, 76 degrees, something way hotter than the set point. So a smart system starts with what you see here, but it adds two things. First of all, it adds an outdoor probe. That measures the outside temperature. It also has an indoor probe. In this case, that would be installed in the floor. So what a smart thermostat system can do is make note of the outdoor temperature, make note of the floor temperature, and also note how much heat the whole room loses. And what it'll do is it will anticipate the heat requirements of the room, and it comes to know how much this particular installation tends to overshoot the set point temperature given an outdoor temperature. It's really quite sophisticated. So for instance, after a few days of operation, your smart thermostat system might come to know that if I want a 72 degree room temperature, it's going to shut off the circulator pump at 70 degrees because it knows that at a given outdoor temperature, the system tends to overshoot the set point by 2 degrees. So in practice, what you get is a much smoother temperature performance in your room. In my experience, when I've installed these systems, they are accurate to within less than 1 degree Fahrenheit. So sometimes a half a degree. So the temperature is very, very even. The comfort level is excellent. And these smart systems aren't really any more expensive than a regular dumb thermostat. So let me take you to an installation I've done and just show you what the equipment looks like after it's installed. So this is a smart thermostat system, or at least the central brain of it. It's made by a company called Techmar. They're a company that makes all kinds of smart stuff like this. The thermostats around the house plug into this, and the outdoor temperature probe and the in-floor temperature probes also plug into this. And this is what decides the anticipation of the temperature and how much a given room will overshoot, how much it has to shut off before the set point in order that it doesn't overshoot the mark. Now, of course, today we're 82 degrees Fahrenheit, so we're certainly not heating, but that number there comes from the outdoor temperature probe, and it's part of the equation that lets this thing be smart.